And then we have another, we can do like.
All right, a couple announcements as we get started. First is that we have an APE study session being held by the ACM Club at 2:30 today in the labs. It's right next door, and the other lab, 216, I think one or the other of them. It may even be both of them. I don't remember. Whatever I posted is the announcement. That is happening today. Highly recommend, if you are taking the APE this quarter, that you should go to that, ask questions of each other. I will be there as well to try to answer as much as I can and help you study. Second, wanted to ask people, how's the lab going? There's a lot of potential struggle places with this lab because the instructions aren't as clear as they should be. What you need to do is not necessarily as clear as it should be. Where to put all of your files is as clear as it should be. If you have not started, please start. This is not something that you can do in a day or two. I'm guessing that there's a reasonable chance I may need to extend the lab anyway, just because there's a lot to this, and especially the first time that you do it. There are going to be a lot of questions that don't come up on future labs that I can help you to do. So get stuck quickly, and I can help you get unstuck so that we can get this in. As I've mentioned before, I'm not the biggest fan of the style and format of the labs, but I have not had time to make something better. So we have to deal with it for the duration of the course, but that also means that I'm more than willing to help you through any of those struggle points. Just know that they are going to be there and you will probably need to ask me about it. I'm very happy to help you through it. It's just, I'm not going to be very much help an hour before it's due if you're starting it then. So get started, get stuck, I'm happy to help.
What is it supposed to, or what will it look like when it's completed?
You will have to run your tests to be able to determine the functionality. So you're not making a driver or a main, it's just a set of tools. And to determine whether that set of tools works or does not work, you will run the test suite and then hopefully have added some more tests to the test suite to make sure that the functionality is there. And you'll find this a lot in the real world is you make tools that are tools. There's no driver, there's no necessary way that you are supposed to interact with this. It's just a set of tools, and then your client is going to be using those tools. So they're not instantiating a driver class necessarily. It's just they have to, eventually a bug will show itself if they try to do something that you haven't anticipated, or the logic that you did anticipate is wrong.
So it's not a game, it's part of the game.
Yeah, I think it's supposed to be some kind of very basic D&D something or other. That uses the strategy pattern.
Yeah, I'm kind of familiar with D&D. My cousins and friends have played it, so I've heard it secondhand.
D&D is phenomenal. If you have not played it before, highly recommend.
It's also kind of complicated, all the stats and whatnot.
Questions about where we are in the course? Due dates for things? What's coming up?
I don't know if you're ready to announce this yet, but if there is a delay, what day do you think it would be delayed to?
That is a very good question. It's something that I would have to look at the schedule for. Unlike with 300, we're not really up against an 8th deadline, but we've now gone over the decorator pattern, which is the next lab. After we finish the code smells, we're going to be going over our 3rd design pattern, which also has a lab associated with it. And then I want to be able to assign the project for the quarter that won't be due until the end of the quarter, but I want you to get started with the design sooner rather than later. I have to make some kind of executive decision about how much I am comfortable delaying this, because some of the feedback that I got last quarter was the end of the quarter felt very work heavy and the beginning of the quarter felt very not work heavy. So I'm trying to bring as much of that forward as I reasonably can, so that people have time and are less crunched at the end of the quarter. The more that I delay it, the more I'm gonna be getting that same kind of feedback about, we're just trying to crunch too much into the end of the quarter. So I want to make it due as soon as possible, which means that as much as possible, get started, get things answered so that we can make it due, so that we crunch less at the end of the quarter. It's in everybody's best interest to get this in, but that said, I don't want to make it due before all of you get your questions answered. Just don't delay getting to that point, and that way we can make it due, get it in, and get you feedback on it as soon as possible.
We'll teach you next.
It's a good question. I want the decorator lab to be due at some point next week. I would like it to be due. I don't think it's as difficult as the strategy lab. Maybe. I think there's a lot of getting used to this style that will hopefully be mostly over with after this lab.
I'm just thinking.
Yeah. Yeah, I will try to avoid.
And you put lab two up.
Yeah, I will get that out as soon as I can so that you can get started with that if you would like to. And that way I'll come up with a reasonable deadline for it. Hopefully that's not right at the 8th. I do recognize that people are very much wanting to do the 8th and focus on the 8th right now. And these labs don't really help with that. I am planning to this Friday do an additional in-class programming problem that we'll be talking about things like how to read and write from files, because that is on the 8th. So I'd like to give people a little bit more practice with reading from files and writing to files. So that's the overall plan for the near future. I know it's not quite as set in stone as people would like, but I leave that flexibility so that as things come up, we have a little bit of flexibility with deadlines. So right now, due Friday. If a significant portion of the class is struggling and wouldn't be able to get it in, obviously I don't want to do before you're happy with your work. So keep in touch with me over the next couple of days, and I am open to extending it on an as needed basis. All right, last time we started talking about code smells. We talked about the 5 broad categories of code smells, and we were diving into quite a few of the bloat ones. We took a look at long methods, where we have overly long methods that do too many things that maybe should be broken down into multiple methods. This happens, especially in industry, as you go back and add functionality to things and add functionality to things and add functionality to things. And as you do this, you don't really think about, should I be making a new method for this? You try to bake it into the existing methods, and that can create some long methods. So recognizing that and being able to factor out how many things is this method doing? If the answer is more than 1 or 2, it might be worth considering the design of splitting it into multiple methods. We talked about large classes. Large classes come about when you want to add functionality. You don't really think, I should make a new class for this. You, again, just like with long methods, you bake it into the existing objects, and then your objects end up doing too much. And an issue that can arise here is that you get tight coupling. You have an object that needs to interact with one method of an object, but that object now has 20 methods. So you end up with something that should be attached really only at that method, but as you make changes to one, you end up needing to make changes to the other in ways that shouldn't necessarily happen. So we'll talk about that more when we get to our couplers, but objects should only be communicating with each other when it's appropriate for them to communicate. You shouldn't need to make changes to an object unless that object is actually needing to be changed, and not just because something that communicates with it needs to be changed. I think we ended with primitive obsession, which was the idea of trying to force everything to be ints, doubles, when they didn't necessarily need to be. So some examples were currency, ranges, phone numbers, stuff like this is very useful to take into your own class. And even if it's a very small class that has a single field that is an int or a double, you can add some additional functionality, like different ways to print your phone numbers, different ways to print your ranges, making sure that there's always a $ and a dot associated with the currency print. All of that can be embedded in just simple methods for an object that you don't have if you only have the primitive type, you're only using the int or the double. We also talked about here at the end, using too many static class constants, public static, final, int, something equals something else. If you do this too frequently, then you actually have to go back and modify each of those values if, for instance, the range changes. Whereas on the other hand, if you use an object or an enum to represent these, then you can find yourself in a much easier situation where it's less code, more easily modifiable. So a few static class constants, perfectly fine. If you end up with more than a few, think about refactoring that into its own object structure. All right, we're gonna start here today with the next bloat. Long parameter lists. We see this a lot when we want to pass information to another object. If, for instance, the object or the method needs a lot of information, we find this a lot with constructors. If you need to pass 10 things onto a constructor, we saw this in the unit testing slides where we were passing a date object and a year and a month and a day and another year and another month and another day to be able to compare two different objects. So we end up with long parameter lists where when the user wants to call a method, they now need to think and remember of all of the different parts of that call. If they get any of those parts wrong, if they mess up the order of those, then you can get some very unintended behavior. Over time, your objects are going to be growing in scope, which means that the constructors are going to need more and more information. The methods are going to need more and more information, especially as those requirements change over time. It's an issue because everything I've already mentioned. So if you need lots of different pieces of data from a single object, like for instance, the date object, if you find yourself passing the year and the month and the day, just pass the whole object by reference. And then within that method, you can dissect that object and use and call the getters associated with those fields rather than passing a bunch of fields. So you can take lots of different parameters and reduce it to a single parameter that is the object reference. If you have lots of parameters from separate objects, but they're passed frequently together. So for instance, you want to pass all of this information together into a database to create a database entry for a particular set of objects. Then maybe you want to define a new object type that is a parameter object that takes in something like an array of those objects, makes that parameter object, and then you can pass just that parameter object rather than a bunch of different objects on at the same time. So think about, from an ease of use perspective, how to reduce the complexity of your method and constructor calls. Questions on anything we've covered so far? All right, the next one, data clumps. We find that we end up storing different pieces of, or similar pieces of data in different parts of our code. So we may have things like an int double int thing that we consistently have in different places in our code. So an example of this would be some of like the parameters for connecting to a database. We always need the same set of parameters for that connection, and we end up with identical groups of variables. This can be identified in general if you are copying and pasting lots of code, especially code for passing parameters. So instead, we can move these variables into their own object and then pass an entire object. As you do this, code size goes down, which is good. You may have one extra class, but then every time that you're passing that long list, you take that long list and make it a single thing. So it's very similar to the long parameter list, but it can also just be wherever you're trying to access a field from here, a field from here, a field from here, some other field from another object, run them all in the same method. Maybe we want to abstract all of those into its own object, and then we can have a single object that we dissect in logic rather than passing and communicating all of that around. One thing to note, as we do this, we can create a dependency between classes. We'll talk about this again when we talk about coupling, but you create a dependency between the classes as you do this, where if one of these object changes, now this object that is a conglomeration of all of these other fields and methods from different objects, this also changes. So you get an extra coupling in your code that you don't necessarily want, or can create additional future complexity if you want to go back and modify either of these objects. That's it for bloat. In general, for bloat, we want to reduce the code size. And we want to improve the code clarity, we want to improve code organization. We want to reduce dependencies that are created by that bloat. We're going to transition now and start talking about object-oriented abuse. We know about object-oriented programming, but just knowing the tools doesn't mean that you're going to use the tools correctly. If you use the tools incorrectly, you can end up with some pretty poorly written and poorly readable, poor readability code. You can end up with spaghetti code, where you make one small tweak to something and an entire sequence of object communication fails, ceases to work.
I'm wondering if whoever names vehicle home did time, or they're thinking about how to game computer or something.
It's fair. So the first one, we have two different classes with different interfaces. So two classes are doing exactly the same thing, but have different method names. Have we seen this before, or we've probably seen it before? I like to refer to something that we haven't quite seen in data structures yet. For instance, the difference between a stack and a queue. If you want to add to a stack, it is called a push, and if you want to add to a queue, it is called an enqueue. They're kind of doing the same-ish thing, adding to it, so having something that's named the same thing makes sense. This is just something that historically has been called this in computer science, and whenever I see it, I facepalm a little bit inside because I think they should be called the same thing. So two classes performing identical functions, but those identical functions have different names associated with them. Not great. So you can rename the methods to make them identical in alternative cases. That's usually the easiest thing to do. You can move around and add parameters such that the method signatures make sense, or they are called in the same way. This is very important when we talk about API design. We talked about API design at the very end of our review lecture, at the very beginning of the quarter. When you're making some kind of tool or system that other people need to use, you want it to be as intuitive as possible. You don't want people to have to refer to the API to know how to make those calls. If you think, let's say, for instance, you're making a linked list, and for some reason, you know that most lists have an add method that adds at the end. If instead you said add at end of the list, and that was the name of your method, it's named differently than you would expect if you were using some other kind of list. And let's say instead of just passing no parameter, you forced it to pass the size of the list for some reason. That's not necessary in order to do the logic, but now me, the user of your linked list code, would have to go look at your API to understand how to add at the end of a list because it's not intuitive to me. So you want to make sure that the methods have the same names across different instantiations of these different abstract data types. You want to make sure that the parameters, the parameter types and number of parameters match across different versions of add that do the same thing. And that just increases the usability of your API. You should minimize the number of times that your clients need to refer to your API to know how to use the tools that you've written. On the other hand, if only part of the functionality is duplicated of a particular class, then you can extract an abstract superclass and use inheritance, and that way everything that's shared in common between those classes is defined in the abstract superclass. Anything that differs is defined in the concrete subclasses. You will find that sometimes you'll go and do these fixes, and then you'll end up with two perfectly identical classes that do exactly the same thing. And you go, oh, I thought these were different use cases, but it turns out that these are exactly the same use case. It just looked different. Now I have two different methods that do exactly the same thing inside of a class that does exactly the same thing. Now you can delete one of them because you see that it's actually the same logic for the same kind of structure. All of that said, if you're trying to merge classes, it's very difficult to do. And it's very easy to make mistakes as you do this. So rigorous testing is very required if you're going to take two different classes and make sure that you can turn that two-class system into a one-class system. If you're going through all of this work and then eventually 20 hours later you figure out, oh, well, there's actually a reason to have these two classes here to begin with, undo all of that work. You want to make sure that you catch that as early as possible so that you can avoid spending 20 hours unnecessarily trying to merge two classes when they should not be merged. If these classes are under different libraries or under different interfaces, they can each absolutely have their own version of that class because clients are going to be importing one library or the other library. So it's perfectly okay to duplicate functionality as long as it's under a different library. Does that part make sense? Like, let's say there's two competing list interfaces. You would want to have the same functionality under both of those list interfaces. So it's perfectly okay to completely duplicate the array list logic, because if you're using one kind of list or the other kind of list, you still want an implementation of an array list, even if it's exactly the same list. How these libraries differ may be in different parts of the code, so it's okay to have that duplicate logic. Questions on this so far? This will not be the most thrilling lecture, I apologize in advance. Just quite a bit of this to get through. Not really a way to make it super exciting. Next one is called refused bequest. So we have an inheritance hierarchy, superclass, subclass relationship. The subclass is going to use only some of the methods or properties that it inherits from its parent. It inherits a lot from its parent, but it's not using everything that it's inheriting. So there may be some methods that are straight up unused or even throw exceptions. So you may be trying to use an object in a way that it's not meant to be used because it inherited something from its parent. And then since it's not defined, it may be throwing an exception. So this can be very common if you have different kinds of objects. So an example of this is we have a legs superclass and we have subclasses animal and chair, because animal legs are very, very, very different from chair legs. They perform very different functions. The methods that would be part of these legs would be very different. So you can imagine inheriting something from this legs superclass that's just not relevant to animal legs or not relevant to chair legs because they're so different from each other. Here's another example of what you can do at the end of this. So we have a stack that inherits from vector. This happens frequently in both Java and C++, whereas now you could compose a stack of a vector. So you're basically turning this into different kinds of objects here. So if inheritance makes no sense, rather we will use the concept of delegation, where you end up saying, all right, if a chair needs to do this, then it looks for the animal legs for the fact that now it's gonna inherit from the animal legs the important things from animal legs, but that's it. Which makes some sense, I guess. If inheritance ends up being appropriate, then we can extract any used fields and methods, and we can find a new superclass for them. And that way you're only getting from the superclass what you need from the superclass, rather than inheriting a bunch of useless methods that might throw exceptions, might break your code just because the client tries to use something that shouldn't be used with it. Switch statements. Oh boy, don't even get me started on these. Did we learn these in 210, I'm guessing? If you're using an object-oriented language, you can just forget that they exist. Because whenever you want to use a switch statement, there's always a better way. They're only useful or necessary in procedural languages that don't support object orientation, like C. So if you have long if statements, large switch statements, something like this, there are object-oriented solutions to doing this that don't use this. And the answer is always polymorphism. Polymorphism allows you to do exactly what a large switch statement would allow you to do, but without all of that code. You just pass in the associated superclass type, and it will know what its subclass type is, so we don't need a long if block to figure out what type it is. Polymorphism just already knows based off of the instantiation of the object. So if you find yourself with a switch statement, you can ask yourself, how can I design a polymorphic inheritance structure that gets rid of the switch statement completely? So you can extract the switch statement, you can move them to a new or different class. So here's an example. If I actually go do this and show you, first and foremost, all of these code smells are on Refactoring Guru. You can see there's a code smells section, and inside of that, here are all of the different types that we've talked about. So if you'd like any information or more visuals about any of these, you're welcome to go look at it. So this concept of replacing a conditional with a polymorphic, we've talked about the problem. We have a conditional that performs various actions depending on an object type or property. So we have an object and we want to say if it's a, let's say we have an animal superclass. If the animal is a dog, do this. If the animal is a cat, do this. If the animal is a horse, do this. We have polymorphism. When we make animal A equals new cat, when you go through the cat constructor, now we know it's a cat. Even though it's stored as an animal superclass, when we go to call A dot walk, it will call the cat's walk. We don't need a big long sequence of if statements to figure out what the object type is. So we want to create subclasses matching the branches of the conditional. So when we say if it's a dog, we should have an object that represents the dog in the inheritance hierarchy of the animal. So in general, as always, if you're studying for this, going back to Refactoring Guru, all of these code smells have a problem, a solution, a why do we care to do this, benefits, the actual process of going through and doing this, all of the steps associated with doing this, and what smell it eliminates. So lots of some work that you can do with code examples. I just don't have time to go over them at quite this level of depth because we have to talk about all the design patterns, and I want to give you some time to work on your project as well. So very good for self-study. My goal in class is to make sure that you have an intuitive understanding of why each of these smells are bad and at a generic level, what you can do about it. If you find yourself identifying a smell in something in your own code, feel free to go to Refactoring Guru and it will give you a lot more detail about what you can do about it. So Why does this lead to better code? There's a object-oriented principle called the tell, don't ask principle, where we have an object, rather than asking another object, are you a cat? Are you a dog? Are you a horse? Instead, have the object tell you what type it is. I am a cat. This is how I walk. And that way you don't need to go through all of the 20 questions to figure out what the type is. So that's the tell, don't ask principle. It also helps you to be able to remove identical conditionals across multiple large if statements or switches. So if in different classes you have the same switch case, of this whole big block across a bunch of places, you replace all of that with this same inheritance hierarchy and you remove the duplicate code that is all of those switch statements. And you have a single inheritance hierarchy that you can now refer to, and your code is much shorter and simpler and more readable. It's just better. If you want to go extend to this, making a new class, now you just add the new class to the inheritance hierarchy rather than trying to figure out where are all of the switch cases in all of my code. I need to add an if statement to each one of those. It's bad design whenever you have to ask yourself, where is this code? How many places did I duplicate this? Did I catch all of them? If you ever find yourself asking that kind of question, it's a design flaw in your code. There should only be one reference to that, and there should be a way that you can just add a class to that that will spread to everywhere that you need to access it, and it should be referring to that one common place. We'll remove tons of nightmares from your future code. Questions on getting rid of switch statements, replacing them with polymorphism? Next one is temporary fields. So we have temporary fields getting their values needed by their objects only under particular circumstances. So if you have an object that has a field, that field should always have a relevant value. It's not something like it's usually null, but it's not null in this one particular circumstance. It should always have a value that is relevant. So outside of the circumstances, they're empty, they're null, they're not relevant. So if we end up needing many parameters, and depending on the parameters that are passed, you're going to instantiate certain subsets of your fields, and that creates the way that your object is going to work. That's object-oriented abuse. Instead, we should have a superclass representing all of the different ways that you could instantiate some of those fields, and then subclasses for each way that that algorithm might be defined, might be called, something like this. So the programmer needs to fill those fields with data, only used when the algorithm is being run. Otherwise, it doesn't have a value, so it's an issue. We can extract the temporary fields into a separate object, and that way the object is either there or not there, and that means you can also make it part of your constructor. As you do this, you get better code clarity and organization, and that is good. So just make sure that all of your fields always have a relevant value. All right, divergent change. We're into our change preventers. So the entire change preventers category is going to be about going back and making modifications to your existing code. What are the roadblocks to going back and making those changes? If you find that your code has those roadblocks, then you're going to be spending a lot of time debugging the issues that you find with your code when you go to make those modifications. So divergent change is the concept of we have a bunch of different unrelated methods. When we make a particular change to a class, we need to change a bunch of different places. So we want to make one change, and that one change requires us to change a bunch of different things in our code. As an example, we have a product library and we want to add a new product type. When we add a new product type, we need to make changes to all of the methods for finding the product, displaying the product, and how the product is ordered. All of those changes need to be made every single time we add a new product. This should scream at you, bad design. What can we do about it? If there are different behaviors of these classes, so the behavior is something like, how do we find, how do we display, how do we order? Extract those behaviors into their own classes. We actually saw this with the strategy pattern, when we were doing this with the duck behaviors, like the quack behavior and the fly behavior. We were extracting those into their own classes and then composing the object of instantiations of those. That is a change preventer. So if we find ourselves needing to make those multiple changes every time we add one of these new objects, instead try to change those behaviors into their own classes and compose them. If different classes have the same behavior, like a quack behavior, then we can make a separate inheritance hierarchy for those behaviors. We had our own separate inheritance hierarchy for quack behaviors. Benefits of doing this: better code organization, reduced code duplication, and if you're trying to support something like this in the future, then it ends up being significantly easier for you to support it because you can easily debug it, easily make the associated changes that you need to, because a change is only going to be in a single place rather than all over the place. If you implement divergent change, you may find that you have the exact opposite issue. So there's an exact inverse relationship between divergent change and shotgun surgery. So it's the exact opposite to the prior problem. Rather than having to make many changes to a single class, it's a single change that has to be made to multiple different classes. So when I want to make a change, now I have to go into every instantiation of a particular subtype and make the associated change. We saw this when we were trying to edit the fly method. When we were trying to make every different duck type fly, if we needed to change how that worked for some reason, if that wasn't in its own superclass in a way that was easily accessible, then we have to go into every single subclass and change every single implementation of that method. So we call that process shotgun surgery.
And I can see why it's just like, okay, one thing. Oh, wait, you're multiple classes. Oh, crap.
Yes.
Well, trying to make this and that together. And then I guess you'll figure the shortcut and hope for best.
It does have a little bit of it's a little bit gross and the term is not the best term, but it's very relevant to what you're kind of doing. A small shard of a projectile is going into every method and making a small change. So any modification you make, you have to make many changes to many different classes. There's another responsibility, with a single responsibility principle in object-oriented design that says that if you make a change, you should only have to make a change in one place. Each object should only be doing one thing, so that if you make that modification, if something needs to be changed, that change only happens in that one place. But that single responsibility, if it's been violated, is in a bunch of different subclasses or a bunch of different objects. So that if you need to make a change, then you have to make a change to multiple different classes. So this violates the single responsibility principle of object-oriented programming and object-oriented programming design. If you overzealously apply divergent change, then you find that you end up with this process, where now if you need to make a single change, because now divergent change, each of those has been split out into their associated classes that do that, it's the exact opposite issue. So you'll find that there's no one right answer. There's going to be some kind of nice middle ground between extreme divergent change and extreme shotgun surgery. The middle ground means that you make changes to just a few places, a couple places, whenever a change needs to be made. It's never going to be possible to fully make it just one place that everything needs to change. These are always recommendations. Do these where it's possible, but it's going to change from project to project that you are working on what the associated solution should look like. So again, these are both tools. They're not the only way, the right way, the only way. We see that all the time in this class. So fixes for shotgun surgery: consolidate existing class behaviors into a single class. You may need to create that class because it may not exist. You can then remove all of the different subclasses and have them exist with that single class. Note that as you make this change, you're going right back to the need for divergent change. So one pro is the other con, one con is the other pro.
So.
Back and forth.
Back again, a little cycle of, I did version, oh crap, focus surgery, cutting your way around it.
Yep, you go too far on one side, you'll swing the pendulum back to the other. So it's about finding that middle ground for your application, what future modifications are most likely to need to be made. If you can identify that, then you'll be able to figure out, is it better to spread out into a bunch of different classes, or is it better to consolidate into a single class? The right answer for that will depend on the project. If you do this, lots of classes can become empty as you try to consolidate into a single class. You may find that you have classes that have no behavior in them. If that is the case, you may be able to remove those classes completely, thus simplifying your code. Some of the design patterns that we're going to talk about will actually help you to figure out where that middle ground should be. If you apply the design patterns, you can minimize the number of changes that need to be made. So benefits of this, you get better code organization, less code duplication, and easier maintenance, if it is appropriate to apply shotgun surgery. These can also become detriments where you get more difficult maintenance depending on, again, the project. Parallel inheritance hierarchies. This one's really fun.
What?
So we will find sometimes when you're going to have two separate inheritance hierarchies where there's a link between the inheritance hierarchies. Anytime you make a change to one inheritance hierarchy, you make a change to another inheritance hierarchy. So it ends up looking something like this, where we have two identical inheritance hierarchies, one on the left, one on the right. Whenever you make a change to this class in this hierarchy, you need to make an equivalent change in this class in this hierarchy. If you find yourself in this situation where you have two parallel inheritance hierarchies, you can compose one hierarchy of the other hierarchy, which means that instead of having this as a base class and these as subclasses and this as a base class and this as subclasses, you compose this with this. So that means that a field in this object is this entire object. A field in this object is this entire object. And now when you make a change to this, this is a field of that. So you can actually make the change logically in just one of the two classes instead of needing to make changes to both classes. So the second hierarchy is gone and is made up of just composition rather than a second inheritance hierarchy. Some benefits, we reduce the code duplication, which is good because there may be some duplication in between this for the associated logic. If you compose it, then you can just access it from the original object. You get better code organization because instead of having to think about two different inheritance hierarchies, you only really have to think about one. Of course, this can also create an even bigger mess depending on the project. So as always, think about what is the result of applying this? Is it going to be worth the time that it takes? So if you want to remove the hierarchy and kind of collapse it in on itself, you can produce even uglier code. When you try to access this fields dot this method dot and some way of doing that, if you create some issues from that, that creates really ugly and unreadable code here, it may just be better to have the parallel inheritance hierarchies and deal with the fact that this is a little bit more complicated rather than creating spaghetti code that nobody can understand. We talked a little bit about comments earlier and how a lot of comments are useless. So the issue, this is probably going to be pretty duplicatory because we've somewhat talked about it, but if your code requires comments that explain what your code is doing, that means that your code is not written well or it's overly complicated. So one, I'm not suggesting that people just delete the comments. You absolutely. I like this because comments are kind of like deodorant. They mask a smell rather than actually fixing the issue. So they just mask the fact that your code is not clear and is not well designed. So comments that you should strive to write are in the code itself. You should not need explanatory comments. The fact that your variables are named what they're named, if that explains what your code is doing, great. That's basically the equivalent of writing a comment, except now you're just reading the code and not reading the code and a description of the code. If your methods are named well, same thing. You don't need to tell me what you're doing if the method is named something that tells me what you're doing. Everything that you need to know about the code should just be embedded in a Java comment at the start of the method. If your code needs more than that, maybe it's actually multiple methods. Maybe your code is overly complicated and there's a simpler way to do what you've already been doing. One way that I think people frequently do this is they put a very complicated expression on a single line, where you're doing a ton of math on just one line. And it's very tempting after that to write a comment that says, this expression calculates whatever it calculates. Rather, split the expression down into components, each of which have variables that represent the names of the components of the calculation. And then rather than explaining what this long expression is doing, you have it in 3 or 4 parts, each of which the variables are telling you what you need. It may seem like that's unnecessary and longer work, but it's really not that much extra work from the computer's perspective. And it will just make your code easier to read. Human time is more valuable than computer time when we're talking about things that have constant complexity. If you pass this code on to a coworker for a code review, and the coworker has to spend an extra 10 minutes trying to figure out what your code is doing, that's 10 minutes of wasted man hours at your company. So code will become more intuitive, code will become more obvious. This is not to say that there are no times that inline comments should exist. Inline comments are great if you want to describe why you implemented something the way that you implemented something. Why did you use this particular algorithm? This algorithm is more efficient for this particular kind of structure. That doesn't belong in a Java doc comment because it's not describing the functionality of the method. You may want to put an inline comment there to explain why you did it the way you did it. Or if it's a very complex algorithm, you may need some additional inline comments to explain exactly how the algorithm is working. So as always, do this where possible, and sometimes inline comments are useful, just not usually. Strive to eliminate them where you don't need them. Duplicate code. You have some code fragments and you look at them and they look like they're kind of the same thing. This seems like something that would very much not happen, but especially as you start working with other people and there becomes overlap in your responsibilities, you will find that they implemented some functionality and you implemented some functionality and they do the same thing, but they implemented it slightly differently than you did. But you look at it and you say, these are doing the same thing, or I think these are doing the same thing. So this happens frequently when you have different programmers working on different pieces of code. You create very similar solutions to the same problem at the same time, because you're both working offline and you're later going to commit your changes to a shared repository. You both solve the same problem at the same time, upload your code, and then only later on, when you're looking at the whole code, realize sometimes the code that they wrote calls their solution and the code that you wrote calls your solution. It will be simpler if you can just have both call one or the other and delete the other. Simpler code, better. This duplication is not always as straightforward as it seems because there are lots of different ways to logically do the same thing. So as you do this, you will find that you're solving the same problem, possibly in vastly different ways. In industry, you're all going to be working up against deadlines very frequently. So it's very easy to just make a quick fix. Even if the functionality exists to solve your problem, if the deadline is tonight, maybe you think, I can just code up something that solves the same problem in a way that is faster than trying to figure out however the heck Hank did it over there. If Hank didn't have good inline comments, didn't name things very effectively, doesn't document his code particularly effectively, rather than, since Hank's off doing something, taking the day off on vacation in Hawaii, and you're sitting here trying to figure out how to use Hank's code and Hank's not there, maybe it's just easier to hack together a solution than it is to do that. You should come back to this later and delete one or the other of your solutions and actually document one of them better. The solution to this really just depends on where the duplicate code is. There's a lot of information in Refactoring Guru for, depending on where that code is, what you might want to do about it. We'll stop there for now. I think we got through most of it. There's probably one more day of this tedious lecture. I don't like lecturing for the whole period. I apologize. This is the one place where I'm really going to be doing it without a ton of examples, but we got to get through it. So one more day of it tomorrow, and then we'll do something much more applied on Friday.